Before they were titans of the digital age, before their names became synonyms with search itself, before the world shifted from wandering libraries to querying a single luminous box on a glowing screen, there were simply two graduate students, Larry Page and Sergey Brin, wandering the Stanford campus with ideas that felt, even then, too large to fit inside the walls around them. They did not know they would build the world's largest AI infrastructure. They did not know they would create the foundation for a new era of computation. They only knew one thing. Human knowledge deserved to be found. Everything else followed. Their story, the story of Page, Brin, and the rise of Google's AI empire, begins not with code, nor with money, nor with power, but with an obsession. An obsession with information, with structure, with how ideas connect, with how machines might one day reason. This is their journey. Larry Page, the engineer born among machines. Lawrence Edward Page was born on March 26, 1973, in East Lansing, Michigan, into a home where computers were not just tools. They were cultural artifacts. His father, Carl Page, was one of the pioneers of computer science education at Michigan State University. His mother, Gloria, was also a computer programming instructor. Family stories recall a house cluttered with electronic parts, computer printouts, and research papers. A young Larry would wander among them the way other children wander through forests. He once said, "I grew up in a home where computers were everywhere. I fell in love with them young, really young. Machines, mathematics, and the idea of organizing information were woven into the fabric of his earliest memories." When he read about Nikola Tesla as a child, Page felt a spark, a fascination with inventors who reshaped the world through sheer audacity. He began to imagine futures where technology would not just assist humanity, but elevate it. This mindset, the mix of engineering pragmatism and moonshot imagination, never left him. Sergey Brin, the mathematician shaped by history. Sergey Mikhailovich Brin was born on August 21, 1973, in Moscow, into a Jewish academic family living under the pressures of Soviet discrimination. His father, Mikhail Brin, was a mathematician, his mother, Eugenia, a researcher at NASA after the family emigrated. At age 6, Brin and his family left the Soviet Union, a journey shaped by political barriers and the hope for intellectual freedom. The experience left a deep impression, a belief that knowledge should never be locked away by governments, institutions, or ideology. At school in Maryland, Sergey gravitated toward mathematics and computers quickly. He was analytical, energetic, and curious, with a personality often described as intellectually fearless. At the University of Maryland, he studied mathematics and computer science with the assurance of someone who saw numbers not as abstractions, but as living entities. When he accepted a position at Stanford for graduate studies, he didn't know he was walking into the partnership that would redefine the modern world. The meeting that almost didn't work. The story of Page and Brin's first meeting has been retold often, sometimes exaggerated for drama, but the core remains true. It was not a meeting of instant friendship. Sergey was assigned to show Larry around Stanford. They debated almost immediately about random topics, about technology, about academic perspectives. The two argued with intensity, yet neither left the exchange annoyed. Instead, each felt the other was interesting. They weren't friends yet, but they recognized a kindred intellectual spirit. The research topic that sparked everything. Larry Page was searching for a research direction, something that matched both his curiosity and his sense of scale. Stanford in the mid-1990s thrummed with innovations. The early web, data mining, networking. Page explored various topics before landing on something deceptively simple: the structure of the World Wide Web. He became fascinated with its link architecture. Each link was a pointer, a vote of relevance, a signal of importance. What if you could map the entire web by analyzing these links? What if you could treat the web like a graph of human knowledge? Page proposed a radical idea. Crawl the entire web. Download all its links. Map its structure. Most dismissed it as too big, too cumbersome, too computationally heavy. But Page was not deterred. He knew that breakthroughs often sounded impossible at first. Sergey Brin soon joined the project, first out of intellectual curiosity, then as a collaborator, and finally as a co-author. This was the birth of Backrub, the research project that would evolve into Google. The innovation behind PageRank. Larry and Sergey realized that counting how many times a web page was linked from others could provide a powerful measurement of its importance. They developed a recursive algorithm, eventually named PageRank, that treated each link as a vote, weighted by the importance of the voting page. It was elegant, mathematically grounded, and, critically, scalable. PageRank changed everything. It allowed the ranking of web pages based on relevance using the web's own democratic structure. Instead of manually curated directories, like Yahoo's early platform, PageRank enabled an automated, data-driven approach. Their academic paper describing the system circulated widely. Professors and researchers recognized its potential immediately. The basement servers. By 1997, Backrub was running on multiple Stanford servers. Larry and Sergey scavenged hardware from anywhere they could find it. They built makeshift racks from cheap materials. They improvised cooling systems. They optimized code obsessively. It was not glamorous. It was raw innovation in its purest form. Two students, a growing web crawler, and the belief that knowledge could be made universally accessible. The more people tried Backrub, the more they insisted. This is better than anything else out there. But Stanford servers were becoming overloaded. Traffic was surging. The project was outgrowing its academic home. The next step was inevitable. When research becomes a company, Larry and Sergey did not set out to be entrepreneurs. They were academics at heart, driven by ideas rather than profit motives. But the sheer usefulness of their search engine made commercialization unavoidable. David Filo, co-founder of Yahoo, encouraged them. You should take this thing and build a company around it. Page and Brin explored selling the technology, even offering it to existing search companies. One early offer was reportedly $1 million. No one accepted. Established companies underestimated the importance of search. In hindsight, this was one of the great miscalculations in tech history. So Page and Brin decided, if no one else will build it, we will. The birth of a name. In 1998, they incorporated their company. The name came from a play on Google, the number 10 superscript 1, symbolizing an unimaginably large quantity of information. It was nerd poetic, a name that captured both scale and ambition. Google, a company born in a garage, a mission born in curiosity, a future no one yet imagined. Susan Wojcicki's garage. The first Google office was the Menlo Park garage of Susan Wojcicki, future YouTube CEO. Rent, $1,700 a month. Inside, a few desks, a jumble of computers, a small team, and a dream to organize the world's information. It was the quintessential Silicon Valley origin, yet unlike the myths of other companies, this one was true in substance, not just story. The first funding. Andy Bechtolsheim, co-founder of Sun Microsystems, visited the garage and saw a demo. Without hesitation, he wrote a check for $100,000 directly to Google Incorporated, which technically didn't exist yet. The founders had to incorporate the company before they could cash it. Soon after came additional funds from Jeff Bezos and other early investors. Google had liftoff. The algorithm was powerful, but the vision was larger. PageRank alone did not make Google the world's leading search engine. What made Google different was a philosophy. Search must be fast, accurate, and unbiased. This philosophy led to innovations that are now standard. Minimalist interface. No banner ads. Lightning-fast results. Objective ranking based on algorithmic relevance. Competitors cluttered their pages with ads, portals, and news. Google presented a blank page, a logo, and a search bar. Users responded immediately. The growth curve. From 1999 to 2001, Google grew explosively. Millions of queries per day. Partnerships with AOL and Yahoo. A rapidly expanding index. Increasingly sophisticated algorithms. Larry and Sergey were becoming leaders, not just of a company, but of a new paradigm in digital information retrieval. Though the world saw Google as a search company, Page and Brin viewed it differently. Search was the first application of AI, not the last. Their earliest engineering decisions reflect this. Building massive clusters of commodity hardware, developing distributed systems to handle global workloads, creating infrastructure designed for machine learning decades before it became mainstream. Even PageRank itself was an early form of graph-based reasoning. The seeds of Google's AI empire were planted in these years, long before the world understood their significance. Larry Page once said, "We want to build the ultimate search engine. It would understand exactly what you mean and give you exactly what you want." This was not search. This was artificial intelligence. By the early 2000s, Google had evolved from a research project into a global utility. Larry and Sergey, now in their late 20s, found themselves leading a company that was redefining how knowledge flowed through civilization. They had not yet built the AI empire for which they are now known. They had not yet created Google Brain. They had not yet invented the TPU. They had not yet integrated machine learning into every fabric of computing. But the foundation had been laid. The garage experiment had grown into the world's most powerful information system. And behind the clean white search box was a deeper ambition, one that pointed far beyond search into the future of AI. This was only the beginning. By the early 2000s, Google was no longer a garage startup. It had outgrown the makeshift server towers built from cheap parts. It had expanded past the Stanford research cluster that had once creaked under the weight of its web crawler. But even as the company grew, Larry Page and Sergey Brin never lost sight of the bigger picture. The future of the internet would not be built by companies. It would be built by infrastructure. And Google, if it was going to fulfill its mission, needed to construct its own. They understood something the rest of Silicon Valley had not yet realized. The scale of human knowledge was expanding faster than any existing computer system could handle. If they wanted Google to index the entire web, and eventually, the entire world's information, they would need a different kind of machine. Something far beyond a traditional server farm. Something distributed, resilient, algorithmically intelligent. The world would later call these technologies Google File System, MapReduce, Bigtable, Spanner, Borg. But in the beginning, it was simply a vision. Build an engine capable of absorbing the totality of human knowledge. The philosophy of cheap hardware. While competitors invested in large, expensive enterprise servers from giants like Sun and HP, Page and Brin insisted on using cheap commodity hardware, thousands of low-cost machines wired together to behave like a single supercomputer. It was risky. Servers failed constantly. Disks burned out. Entire racks died without warning. But the brilliance was in the software. Failures weren't bugs. Failures were normal. The system was built to survive them. This philosophy seeded Google's core engineering culture. Resilience through redundancy. Scale through distribution. Speed through parallelism. Intelligence through data. It also seeded the development of the technologies that would later reshape the entire world of data processing. Google File System, GFS, the first great leap. Google needed a way to manage petabytes of data across thousands of unreliable machines. The answer became GFS, a file system designed to split data into chunks, distribute chunks across machines, automatically replicate them, self-repair when failures occurred. GFS was more than a file system. It was the architectural skeleton of Google itself. Years later, public academic papers describing GFS would directly inspire open-source projects like Hadoop, which in turn catalyzed the era of big data analytics across the entire tech world. But at the time, GFS was a secret weapon. Only Google knew how to build machines at this scale. MapReduce, programming at planetary scale. GFS solved storage. The next challenge was computation. Web crawling, indexing, ranking, and analyzing massive datasets required a programming model that could operate across thousands of machines simultaneously. Jeff Dean and Sanjay Ghemawat, two of Google's early engineering legends, developed MapReduce, a framework that allowed tasks to be split into map tasks, distributed across machines, combined using reduced tasks. MapReduce was elegant, powerful, and simple enough that engineers could build massive applications without knowing the underlying complexity. Larry Page was thrilled. Sergey Brin was ecstatic. This, they knew, was the engine that would push Google into a new universe of scale. Bigtable, Borg, and beyond. The innovations continued. Bigtable, a distributed storage system for structured data, later powering Google Earth, Gmail, and more. Borg, Google's internal cluster manager, decades before Kubernetes would bring the concept to the wider world. Protocol buffers, Chubby, Colossus, each part essential, each reflective of the same philosophy, build for the entire world's data, not just today's needs. By 2004, Google had quietly created the most advanced data processing infrastructure ever built. Investors marveled at the search engine. Users marveled at the clean interface. Competitors marveled at the speed. But engineers inside Google knew the truth. Search was just the surface. Underneath was an entire planet-sized company. The search algorithm evolves. PageRank remained the heart of early Google search. But as the web exploded in size, the algorithm needed to evolve. Google added query expansion techniques, semantic analysis, spelling correction via statistical models, synonym detection, language modeling, user behavior signals. Each improvement pushed Google closer towards something remarkable. Understanding. Search was becoming less mechanical, more interpretive. The system began to infer intent, not just match text. When users typed weather, they no longer saw websites about meteorology, they saw their local forecast. This was not mere engineering. It was the dawn of machine reasoning. Larry Page's obsession with AI. Larry Page spoke often and openly about his dream of building AI. To some, it sounded like science fiction. To Page, it was the logical end of Google's mission. He said, "The perfect search engine would understand exactly what you mean and give you exactly what you want." He didn't say retrieve. He said understand. This shift from retrieval to understanding guided everything Google built in the early 2000s. Sergey Brin's mathematical vision. Where Page dreamed in systems, Brin dreamed in patterns. He was deeply influenced by probability theory, graph structures, statistical modeling, linguistics, information retrieval research. He loved clustering algorithms. He loved dimensionality reduction. He loved the emerging field of statistical machine learning. Brin once said, "To organize information, our systems have to perceive the world in ways that echo human cognition." Together, Page and Brin were not just building a search engine. They were building the first global AI substrate. August 19, 2004, a quiet detonation. Google went public in 2004. The IPO raised $1.67 billion. Larry Page and Sergey Brin each became billionaires overnight. The company was valued at more than $23 billion. But while the media focused on wealth, the founders focused on freedom. Google was now a company with immense resources. Resources they intended to pour, not into profit, but into moonshot engineering. And nothing consumed more of their imagination than artificial intelligence. The investor letter, a declaration of intent. Google's IPO letter was unusual. Where most companies wrote about predictability and profit, Page and Brin insisted. Google would remain unconventional. Google would invest boldly. Google would place long-term bets. Google would prioritize its mission over quarterly results. It was not a typical corporate statement. It was a manifesto. One line in particular resonated through Silicon Valley. "We will not shy away from high-risk, high-reward projects." Everyone knew what the founders truly meant. AI, a new era of machine learning. By the late 2000s, deep learning was re-emerging from decades of skepticism. Researchers like Geoffrey Hinton were reviving neural networks using GPU acceleration. The possibilities seemed immense, but most institutions lacked the infrastructure to train large models. Google did not. Jeff Dean, Andrew Ng, Greg Corrado, and others began researching how to scale neural networks across Google's vast clusters. The result was Google Brain, founded in 2011. It began quietly, almost experimentally, just a small group of researchers working with computational resources no university could dream of. Their first public demonstration stunned the world. The cat experiment. In 2012, Google Brain announced a breakthrough. They trained an unsupervised neural network with 16,000 CPUs, 1 billion parameters, and without labels, without supervision, the model learned to recognize cats. Critics laughed, but AI researchers understood the magnitude. For the first time, a machine identified a complex visual concept without being explicitly taught. This single experiment lit a fire that would ignite the modern deep learning revolution. Google Brain was real. Its potential was limitless. Page and Brin's reaction. When Larry and Sergey saw the results, they immediately recognized what it meant. This wasn't a novelty. It was a capability. Something was emerging, something akin to perception, abstraction, intuition. Page reportedly told colleagues, "This is the beginning of where we must go." Brin, more exuberant, reportedly expressed it differently. "This changes everything, transforming every product." Following Google Brain's breakthroughs, deep learning began infiltrating every layer of Google's ecosystem. Gmail used machine learning for spam detection. Google Photos learned to recognize faces, objects, and memories. Translate leapt from phrase-based systems to neural translation. Search integrated neural embeddings into ranking signals. Maps used machine learning for traffic prediction. Ads optimized relevance using massive models. It was subtle at first, invisible to users, but transformative. Google was no longer a search engine company. It was an AI company. The hiring of Jeff Dean, the architect of scale. Jeff Dean became the technical face of Google's AI revolution. He had already revolutionized distributed computation. Now he was leading the newly formed Google Brain team. Dean combined academic brilliance with an engineer's pragmatism. He could build research systems that actually worked at global scale. Under his oversight, TensorFlow was created. Neural translation models were scaled. Speech recognition transformed. Reinforcement learning gained industrial traction. Page and Brin trusted him deeply. He was, in many ways, the engineer they had always been looking for. TensorFlow, the AI framework heard around the world. In 2015, Google released TensorFlow as open source. This was not an act of generosity alone. It was a strategic masterstroke. By releasing TensorFlow, they standardized the world's AI research on Google's ecosystem. They accelerated the rise of machine learning. They strengthened Google's position as a platform, not just a product. It was one of the most influential decisions in the history of AI. The problem of scale. Training large neural networks required unprecedented computational resources. Even Google's clusters strained under the workload. Page and Brin understood. If AI is the future, AI needs its own hardware. Thus began the project that would lead to one of the great engineering achievements of the century. Tensor Processing Units, TPUs. Designing the brain's engine. Google engineers designed TPUs to accelerate matrix multiplication, neural network training, inference at global scale. The first TPU was deployed in Google data centers secretly. Even many inside the company didn't know. When revealed publicly in 2016, it stunned the industry. It wasn't just faster than GPUs, it was specifically crafted for deep learning. Larry Page's long-range thinking. For Page, TPUs fulfilled a vision he'd held for years. If you want AI to flourish, it must have a native habitat. TPUs became that habitat, dense, efficient, and optimized. They powered Google Search, Google Assistant, Photos, Translate, every deep learning system inside Google. Today, TPUs remain one of the foundational pillars of Google's AI infrastructure. While AI research accelerated, Page and Brin were simultaneously building another empire, Google X, later X, the Moonshot Factory. Here, they pursued ideas that felt like science fiction. Self-driving cars, Waymo. Internet balloons, Loon. AI-driven drone delivery, Wing. Project Glass. Robotics initiatives. Quantum computing research. This was Google operating in its purest form, a company that believed technology should not just improve the world, it should transform it. Waymo, in particular, became the embodiment of Page and Brin's ambitions. 9. The threshold of transformation. By the mid-2010s, Google had completed a journey few companies ever achieve. It built the world's largest computing infrastructure. It pioneered distributed systems still unmatched in capability. It fostered a research environment producing breakthroughs annually. It became the epicenter of the global AI revolution. Larry Page and Sergey Brin were no longer merely successful founders. They were the architects of the modern AI ecosystem. But their story was far from over. The next chapter would mark the transition from innovators to visionaries, leaders whose ambitions would reshape not just the internet, but the direction of civilization itself. The late summer air at Stanford in 1995 carried the faint scent of eucalyptus, dry, crackling leaves that lined the long sidewalks curving around the campus like veins. Students from every corner of the world wandered between the sandstone arcades, their excited chatter blending with the hum of bicycles and the occasional, rebellious skateboard. It was a place where ideas collided like charged particles, sparking with the electricity of possibility. Yet, beneath the sun-soaked terracotta rooftops, two young men were unknowingly approaching one of the most consequential meetings in technological history, an encounter that would alter not only their fates, but the very structure of modern knowledge itself. Larry Page arrived first. He stepped out into the bright courtyard outside the Gates Computer Science building, squinting slightly, shoulders angled forward in a posture halfway between shyness and relentless curiosity. A Michigan native, he carried something of the Midwest in his demeanor, a quietness, a contemplative steadiness, but his eyes betrayed a different truth. They were sharp, bright, as if perpetually scanning the world for its hidden systems. To Larry, everything was a network waiting to be untangled. The world was an engineering problem that simply hadn't met an engineer clever enough yet. He walked with a careful energy, each step suggesting he could pivot at any moment toward a new idea, a new question, a new challenge. What drew him to Stanford was not merely graduate study, but a gravitational pull, the sense that Silicon Valley was the place where the future was being sketched in pencil, waiting for someone bold enough to ink the lines. Sergey Brin, however, arrived like a gust of kinetic wind. He moved with the confidence of someone who had already outmaneuvered the improbable, from a childhood in Moscow constrained by anti-Semitism, to an immigrant adolescence in Maryland, to a mathematics prodigy who seemed to solve equations as if conducting an orchestra. Sergey entered the courtyard talking rapidly, gesturing with his hands as though equations lived in his fingertips. "Look, the structure of the problem is wrong," Sergey exclaimed to the student walking beside him, who nodded furiously. "You don't reduce a dimensionality issue by pretending it doesn't exist. You embrace it. You build the structure around it." He paused mid-sentence as he noticed Larry standing alone near the bench. Something in Larry's thoughtful stillness caused him to raise an eyebrow. "You're the new guy," Sergey said, more observation than greeting. "And you talk a lot," Larry replied, equally observational. They looked at each other, a hesitation of two minds evaluating the other's orbit. And then Sergey burst into laughter, delighted. Within the first 60 seconds, both decided they disliked each other. That, in hindsight, was the perfect beginning. The friction that creates sparks. Their first conversation, which would later be retold in thousands of interviews, books, and documentaries, was not a warm exchange. It was a collision of ideas, theories, and academic egos. "I read your proposal," Sergey said point-blank, sliding onto the bench beside Larry as though claiming it by right. "Something about downloading the entire World Wide Web? Seems excessively ambitious. And wasteful." Larry's jaw tightened. "It's not wasteful. It's necessary. You can't understand the structure of the web unless you have the whole thing. The linking patterns are everything." Sergey tilted his head. "You realize the web doubles in size almost every year, right? That's why it needs to be understood," Larry countered. The world is building a massive library with no catalog. It's chaos. Someone needs to impose order. Sergey crossed his arms. Order is overrated. Larry smirked. Spoken like someone who's never tried to find anything online. The two stared at each other, neither blinking, their disagreement so intense it might have seemed personal. But beneath that friction lay recognition. They were both visionaries, just different wavelengths of the same light. Their arguments continued for weeks. Professors would overhear the heated debates spilling into hallways, classrooms, even parking lots. Some students began referring to them as the two comets, hurtling through Stanford's academic atmosphere on unpredictable trajectories. You two should either collaborate or stay at least 100 meters apart, one professor joked. They chose the former, a partnership forged in restless curiosity. The decision happened on an unusually cool October evening. Larry was in his dorm room, papers sprawled across his desk, scribbling diagrams about link relationships. The room was dim except for a desk lamp casting a triangle of light onto the mess of printouts. He stared at the diagrams, frustration mounting. He understood the web structure, but the mathematical backbone of the problem felt slippery. A knock came at the door. Sergey stood in the hallway, no introduction needed, holding a notebook stuffed with equations. "I've been thinking about your idea," he said, pushing past Larry into the room uninvited. "It's not completely ridiculous. Mathematically, it could work." Larry snorted. "High praise. Don't let it go to your head," Sergey retorted. "But the linking structure, there's something there. A hierarchy, a recursive ranking. Pages that are important because important pages link to them." "That's exactly what I said," Larry replied. Sergey tapped his notebook. "But you didn't know how to express it." "I think I do." Larry leaned forward. "Show me." What followed was not merely collaboration, it was combustion. They worked until dawn, scrawling formulas, sketching graphs, challenging each other's assumptions. They argued. They laughed. They yelled. They rewrote entire sections of their logic only to throw them out and begin anew. But by sunrise, a simple idea had taken shape. So simple that it seemed absurd no one else had seen it. A web page's importance could be determined by how many other important pages linked to it. The logic was recursive, elegant, beautiful. Sergey sat back, rubbing his eyes. "PageRank," he murmured. Larry raised an eyebrow. "Named after the algorithm's ranking function? Or after me?" Sergey shrugged with theatrical innocence. "Both? Why not?" They laughed. The shared laugh of people who suddenly realize the ground beneath them has shifted forever. The birth of an empire inside a dorm room. The work became an obsession. Larry and Sergey built their prototype inside Stanford's server rooms, commandeering machines with an audacity that both shocked and amused the system administrators. They wired together outdated computers, stacked them on floors and desks, and assembled what might generously be called a cluster. A cluster held together with literal duct tape and the stubborn conviction that the web's secrets could be extracted by force. "You know, this is technically against several rules," a network admin told them one afternoon. Sergey barely looked up from the terminal. "We're doing science." "It's not that scientific," the admin replied. "And you're going to melt the servers if you keep running crawlers at this speed." Larry swiveled his chair. "Then maybe Stanford should buy better servers." The admin sighed, defeated. "Just warn me before things catch fire." By late 1996, their engine, originally named Backrub, an inside joke referencing the backlink system, was indexing more of the web than most existing search engines. It was crude. It was unstable. It occasionally crashed an entire building's network. But it was powerful. People who used it were startled by how accurate the results were. "It feels like the system knows what I mean," one doctoral student remarked. "It's not magic," Sergey replied with a grin. "Just math." But Larry knew it was more than math. It was the beginning of a new way of navigating human knowledge. The moment of realization. One evening, while testing queries in the dim glow of the lab, Sergey typed a single word. "Stanford." The result populated instantly. Not with random pages. Not with spam. Not with irrelevant lists. But with the actual, authoritative Stanford homepage. Sergey blinked. "Do you see what this means?" Larry nodded slowly. It works. It actually works. No, Sergey said, shaking his head. It understands. Larry leaned back, exhaling. We're building something the world doesn't realize it needs yet. Sergey looked at the screen, the simple interface, the plain blue links that would soon become iconic. What do we call it? They toyed with names, but none felt right. Until one day, a friend suggested a mathematical term. Google, 10 superscript 1. A number so vast it bordered on the infinite. Perfect, Larry said. Because that's what we're organizing, everything. Sergey nodded. A misspelling could even make it easier to trademark. And so, Google was born from a typo and a dream too large to articulate. Friction, friendship, and the furnace of ideas. Their partnership was far from simple. Larry was quiet, methodical, strategic. Sergey was fiery, improvisational, instinct-driven. They argued over everything: code architecture, interface design, even whether the search bar should be centered on the page. You center nothing, Sergey insisted. White space is inefficient. White space lets people think, Larry countered. The interface should reflect the clarity we want to bring to the world. You're romanticizing blank space. You're allergic to minimalism. Yet, when it mattered, they defended each other with fierce loyalty. In faculty meetings, when professors raised concerns about the privacy risks of crawling email servers for research, Sergey stepped forward, shielding Larry's more confrontational impulses. This is research, he argued, not espionage. We are building the future of information. And when Sergey's exuberance led to friction with administrators, Larry stepped in with calm, reasoned explanations, smoothing the waters and keeping the peace. They were opposites, yes, but complementary opposites. Two sides of the same extraordinary coin. A future too big for academia. By 1998, the search engine had grown so large that it exceeded the capacity of Stanford's network infrastructure. Administrators delivered an ultimatum. You need to move this project off campus. Larry and Sergey exchanged glances in the hallway outside the dean's office. They weren't ready for a company. They weren't even sure what a company should do. They were researchers, scientists, builders of systems, not corporations. We could just shut it down, Larry said quietly. Sergey looked at him, surprised. Shut it down? After everything. I'm saying we don't know what we're doing. That never stopped people like us, Sergey replied. Larry, look around. This isn't just a school project anymore. This is becoming the spine of the internet. Larry sighed. We would need funding. Then let's get funding. We don't know any investors. Sergey smirked, already taking out his bike keys. I know one who owes me a favor. The garage that became a kingdom. The investor was Andy Bechtolsheim, one of the founders of Sun Microsystems, and a man known for his uncanny ability to sense technological inevitability. They met him early one morning on a patio in Palo Alto. Sergey did most of the talking, animatedly explaining PageRank, the crawler architecture, the indexing system. Larry chimed in when Sergey's enthusiasm began to exceed technical precision. Bechtolsheim listened silently, fingers steepled, gaze drifting between the prototype running on a laptop and the two young men radiating conviction. Then he said a single sentence. I can't stay long, so let's just get this done. He pulled out his checkbook, wrote a check for $100,000, made it out to Google Inc. At the time, this company did not legally exist. Sergey blinked. We don't actually have a corporation set up yet. Bechtolsheim shrugged. Then go make one. Just don't waste time. Thus began the empire, from a garage in Menlo Park belonging to Susan Wojcicki, who would later become CEO of YouTube. The garage was cramped, chaotic, and smelled faintly of motor oil and burnt solder. But it was holy ground. This was where the young world builders would take their first steps toward building an informational universe. Google expanded quickly, too quickly for anyone to fully comprehend. The search bar became the gateway to knowledge for millions, then billions. People no longer looked up information, they Googled it. But beneath this surface success, something deeper was happening. Larry and Sergey were beginning to understand that search was only the beginning. The web was growing exponentially. Data was proliferating at a rate that bordered on the unquantifiable. Human knowledge was expanding faster than any system in history could manage. Except one that learned, one that adapted, one that could think. The birth of an AI empire, before the world knew to call it that. In the early 2000s, when artificial intelligence was still mostly a research curiosity, Larry Page quietly began assembling a team. Not just software engineers, not just search experts, but machine learning pioneers, visionaries, people who believed that the next evolution of search was not indexing the web, but understanding it. Sergey supported the vision wholeheartedly, though he focused heavily on the mathematical and computational depths required to make it real. They gathered researchers like Jeffrey Hinton, Jeff Dean, Andrew Ng, and Fei Li, people whose names would later define the field. They built Google Brain, TensorFlow, and later the TPU, an accelerator chip for machine learning that would reshape the computational landscape. Bit by bit, quietly and steadily, Google became not just a search engine, but the world's largest AI infrastructure. The modern AI era had not yet begun, but Larry and Sergey were already building its skeleton. Someday, Larry said to Sergey during a late-night walk through Mountain View, the world will rely on intelligent systems for everything. Understanding language, understanding images, understanding the world. Sergey looked at him, eyes glinting. And we're going to build them. Larry nodded. We already are. Section C, the algorithm that changed the world. Sergey Brin hunched over his workstation in the dimly lit corner of the Stanford Computer Science Lab, the glow of CRT monitors reflecting off his glasses. He had a habit of squinting slightly whenever he concentrated deeply, an expression that made him look equal parts curious and mischievous. That afternoon, the lab buzzed with the usual symphony of whirring machines, clattering keyboards, and muffled conversations about bandwidth bottlenecks and linear algebra proofs. But in Sergey's corner, something else stirred. He had been poring over a paper on citation networks, fascinated by the way academic influence could be mathematically modeled. It felt oddly poetic to him, an entire world of human knowledge distilled into nodes and edges, rising and falling in importance based on the echoes of reference and memory. If ideas were the currency of progress, citations were the trails they left behind. But something in the math felt limited. Citations were useful, yes, but they didn't explain why some ideas resonated while others vanished. He felt there must be a deeper structure, a hidden architecture underlying human judgment. Then Larry Page walked in. Larry was carrying a stack of printed research papers under one arm and a bottle of Diet Coke under the other. He set the papers down with a thud beside Sergey's keyboard. You've got to look at this, Larry announced before Sergey could even greet him. Sergey raised an eyebrow. Linear algebra again. No, Larry replied, brushing aside a dusty monitor cable. The entire internet. Sergey blinked. Once, twice, trying to process the sheer audacity of the statement. Larry, he had learned, was capable of saying the most outrageous things with a tone so matter-of-fact it forced you to consider whether he might actually be right. Explain, Sergey said. Larry pulled up a chair. We've been thinking about search all wrong, he said. Everyone is trying to index keywords, but keywords don't tell you much. What matters is structure, how pages connect to each other. Think of the whole internet as a giant graph. Sergey leaned back, folding his arms. A graph with billions of nodes and trillions of edges. Larry grinned. Exactly. It was absurd. It was impossible. It was the most interesting thing Sergey had heard all week. Larry clicked through a crude prototype of the crawler he'd been building. The screen showed a dense web of nodes, each representing a web page, each link representing a hyperlink, tiny digital handshakes between distant strangers. The data was chaotic, messy, incomplete. But somewhere inside it was a pattern, waiting to be revealed. What if pages voted for each other? Larry continued. Every hyperlink is a kind of vote. If a page has more votes, maybe it should be considered more important. But, Sergey cut in. Not all votes are equal. Larry nodded. Exactly. A link from a more important page should count more. So importance becomes recursive. A page is important if important pages link to it. It's like a feedback loop. Sergey felt something electric stir inside him. A recursion-based ranking model, a global iterative computation over the entire web graph. It was bizarre, elegant, and powerful. It's like academic citations, Sergey said slowly, but without the academic snobbery. Larry laughed. Exactly. Sergey grabbed a notepad from beside the keyboard and began scribbling frantically. He wrote matrices, eigenvectors, convergence functions, math he had always loved for its clean predictability, but had never imagined applying to a digital wilderness as unruly as the web. And then it happened. A moment of pure intellectual synthesis, a collision of insight between two young minds whose curiosity burned like twin comets streaking across the Stanford night. Larry leaned forward. We need an algorithm. Sergey looked up from the notepad. We already have the idea. We just need to express it mathematically. Larry's eyes gleamed. A rank for every page. A page rank, Sergey said without thinking, then froze, realizing the accidental pun. Larry burst into laughter. Yeah, he said, wiping his eyes, but spelled PAG. Sergey smirked. Of course. They both paused, staring at each other, recognizing they had just named not only an algorithm, but perhaps an empire. Sergey typed rapidly, building a function that approximated the value of each page based on the importance of incoming links. Larry paced behind him, tossing out suggestions, refining the logic, challenging assumptions. The process was chaotic, messy, exhilarating, two minds spiraling upward together, discovering a structure in the noise. Hours passed. Night deepened. The lab emptied. Still, they worked. Finally, Sergey hit enter. The first PageRank results appeared. They were crude, incomplete, but astonishingly promising. The algorithm behaved intuitively. Pages with strong references rose to the top. Obscure spam dissolved into insignificance. They had uncovered something almost primal, a mathematical reflection of how collective human attention organizes itself. Sergey sat back, exhaling. This might actually work. Larry nodded slowly. This could change everything. They didn't know, of course. How could they? That the lines of code glowing on the screen would one day form the foundation of the world's first true AI-scale data engine. That PageRank would become the heartbeat of a company destined to command the world's knowledge, transform global commerce, revolutionize information retrieval, and eventually give birth to an AI ecosystem spanning every continent and industry. All they knew, in that moment, was the thrill of creating something beautiful. The algorithm was their symphony, the web, their orchestra, the world unsuspecting. And somewhere in the quiet hum of the Stanford lab, the future of artificial intelligence took its first breath. Section D, the prototype that shocked Stanford. At first, PageRank was just an idea, an elegant mathematical curiosity hidden in the quiet corners of a Stanford lab. But ideas, Larry reminded Sergey one morning, didn't change the world by sitting inside notebooks. They needed form. They needed teeth. They needed a machine that could unleash their potential across the unruly expanse of the early web. They needed a search engine. The name, at the beginning, didn't matter. It wasn't Google yet. It was a sprawling collection of scripts, crawlers, and hacked-together servers that rattled like shopping carts full of loose screws. But it worked, barely. Larry and Sergey began with a scavenger hunt across campus. Stanford's computer science department had a habit of leaving old hardware scattered in forgotten rooms, hallways, and storage closets. The two hunted for discarded CPUs, mismatched RAM sticks, half-dead power supplies, anything that still breathed life when plugged in. They found one machine in a recycling pile, covered in dust, and taped with a note that read, "Do not use." Unstable. Sergey picked it up anyway. Perfect, he said. They built their first server towers using cheap plastic enclosures and whatever parts they could Frankenstein together. They duct-taped entire racks when screws went missing. They stacked hard drives in cardboard boxes. The system ran hot, too hot, so they added fans that roared like jet turbines. But for all its ugliness, their creation had a pulse. It could crawl the web faster than anything else at Stanford. It could compute PageRank scores across tens of thousands of pages. And it could return search results so relevant that the system felt uncanny. The first real test came at midnight in the Stanford server room, an echoing, fluorescent-lit cathedral of humming machines. Larry typed a simple query. MIT Computer Architecture. He hit enter. The list that returned looked nothing like what the existing search engines, AltaVista, Lycos, Excite, produced. Instead of random keyword matches and spammy pages stuffed with useless text, the prototype delivered articles from respected researchers, leading labs, foundational papers, and key lectures. Sergey stared, almost suspicious. Run something more ambiguous. Larry cleared the query and typed, Best Pizza Palo Alto. He hit enter again. This time, the algorithm surfaced local reviews from Stanford students, discussion threads, and even a small website from a local pizzeria whose owner had uploaded a hand-coded HTML menu. Sergey's eyes widened. You're kidding me. It's all link structure, Larry murmured, staring at the screen. The web is telling us what it finds important. Sergey ran his own query. Einstein Relativity Lecture Notes. The result returned a little-known digital archive maintained by a European university, a page Sergey didn't even know existed. He sat back. This is like telepathy. Larry grinned. No, this is mathematics. Word spread across campus quickly, first among their friends, then among graduate students, then among professors. Someone whispered about the magical search box in the basement. Others said the new engine felt alive, as if it understood intention rather than mere text. Soon, Stanford servers were groaning under the weight of increased traffic. Larry and Sergey patched and expanded their machine daily, crawling the web relentlessly. They bought more drives, begged for more rack space, and rewired power strips in ways that would have made the campus fire marshal faint. Yet the more people used the system, the more something extraordinary happened. The search engine learned. Every new link, every new crawled page, every fresh dataset made PageRank smarter. The web itself was growing, and so was the algorithm's understanding of it. The system didn't just index information, it interpreted relationships, discovering the architecture of global knowledge. In the cafeteria, undergraduates whispered about it between bites of burritos. In the engineering building, doctoral candidates gathered around hallway whiteboards to speculate about how the ranking function worked. A professor even stopped Sergey after class to ask, "What exactly have you two built?" Sergey hesitated, choosing his words carefully. "A reflection of the web's collective mind," he said. The professor laughed, assuming it was a metaphor. Sergey didn't correct him. Late one night, after hours of debugging, Larry slumped into a rolling chair and stared at the server racks, glowing, blinking, humming like a choir of digital monks chanting patterns only they could hear. Something about the atmosphere made him feel as if they were standing on the threshold of an unseen world. Sergey sat beside him, quietly sipping a can of orange soda. "Do you think," Sergey murmured, "that this is just a tool? Or is it the beginning of something bigger?" Larry didn't look away from the servers. "The web is the world's memory, and we just found a way to read it." Sergey thought about that for a while. Then he said, "We need a name." Larry smirked. "For what? Our duct tape monster?" "No," Sergey replied. "For the future." For days they debated possibilities. Backrub, their first name, sounded unintentionally creepy. Wattbox, WattSeek, QueryNet, none carried the weight of their vision. Then, during a brainstorming session, someone stumbled on the mathematical term Google, the number 10 superscript 1. A number so vast it represented infinite possibility, boundless information. Sergey altered the spelling. Google. They both stared at the words scribbled on the whiteboard. It felt childish and cosmic at the same time. Simple, playful, limitless. Larry nodded. Google it is. They didn't know yet that this name would someday echo across every continent, every classroom, every smartphone, every language. That it would become a verb, a mirror, an oracle. That it would build the world's most powerful AI infrastructure. But standing in that tiny room, surrounded by humming Franken servers. They felt the first tremors of destiny. Google had been born, and the world would never search, never think, the same way again. How Google became the silent engine of the world's intelligence. By the early 2000s, the world had awakened to the web, but not yet to its scale. Every minute, people were typing, uploading, linking, writing, searching, and leaving behind a digital trail. Blogs erupted like wildflowers. News sites multiplied. Forums that looked like chaotic mosaics of humanity sprouted across the globe. Humanity was speaking, and Google was listening. As the web expanded, so did the demands placed on Google's infrastructure. The company grew from two founders and a few ad hoc servers to a team of engineers, designers, and dreamers who believed, sometimes irrationally, that information should be universally accessible and useful. But something else was happening beneath the surface. Google was becoming the de facto memory of the human world. Its search logs were a mirror of global curiosity, indexed by the second. Its crawlers explored every reachable corner of the internet, like tireless cartographers mapping the world's knowledge. Its users, hundreds of millions of them, unknowingly helped refine the ranking algorithms with every query. Yet Larry Page sensed a pressure building in the seams. He saw it late at night, staring at the dashboards in Google's early data center, the graphs rising like unstoppable tsunamis, traffic that doubled every few months, index sizes that ballooned beyond predictions, new languages, new file types, new kinds of questions, questions that the old tools could not answer. Sergey felt it too. He once said to a colleague, "Search is not the limit. It's the foundation. There's something larger waiting beyond it." Both of them sensed the same truth. The world wasn't just searching for information anymore. It was yearning for understanding. Search needed to evolve. Google needed to evolve. The next transformation wouldn't be about pages or websites or keywords. It would be about intelligence. But first they needed power. Computational power on a scale the world had never attempted. Before the public even knew what cloud computing truly meant, Google had already begun constructing the backbone of the modern AI era. Not one data center, not two, but dozens, each a cathedral of metal racks, fiber pathways, geothermal cooling systems, high-voltage transformers, and warehouses filled with servers designed in-house. They were placed strategically near rivers, hydro plants, and fiber backbones. Most people would never see one. Few engineers even visited more than a handful. They were the most important buildings of the information age. Inside them, something extraordinary was happening. Google invented the modern supercomputer by distributing it across the planet. The scale was incomprehensible. Tens of thousands of servers, then hundreds of thousands, then millions, dedicated to crawling, indexing, training, ranking, translating, predicting. Larry loved the hardware side. He spent hours with engineers debating cooling systems, power distribution, and how to reduce latency by fractions of a millisecond. Sergey bounced between labs, pushing research teams to stretch beyond what they believed possible. Every new expansion solved a problem, but created another. Every upgrade pushed the frontier, but exposed a deeper need. Google wasn't building infrastructure for search anymore. It was building infrastructure for artificial intelligence. One night, while touring a newly completed data center carved into the side of an industrial plane, Larry looked across the expansive maze of racks, glowing with the soft blue LEDs of a million humming machines. He whispered, "This is our brain." Sergey added, "No, this will be humanity's." They hadn't yet created the models, the neural networks, the breakthrough architectures that would one day be synonymous with AI. But the stage was set. Google had created the computational world where intelligence could be born. The beginning was almost accidental. It started with a handful of researchers, Jeff Dean, Greg Corrado, Andrew Ng, and a quiet wave of brilliant engineers tucked under the umbrella of an experimental project. The mission was bold. Could Google build neural networks at a scale no one had attempted before? Larry believed yes. Sergey believed absolutely yes. Jeff Dean, legendary for his ability to rewrite entire systems with a few lines of code, believed it could be done elegantly. Andrew Ng believed it could change everything. Early on, they trained a neural network with 1,000 machines, an unthinkable scale at the time. The model began to recognize patterns in YouTube frames without any labels. No human told it what a cat was. It learned. Organically. Silently. Unsupervised. When they told Larry Page, he leaned back in fascination. It discovered the concept of a cat, simply because humans upload so many cat videos. Jeff Dean nodded. Larry's eyes glittered. Proof, he whispered, that intelligence is emergent, not programmed. That moment was the birth cry of Google Brain. From that point forward, AI was not just a research initiative. It was the destiny of the company. The team scaled models, scaled data, scaled compute. Every breakthrough fed into Google's infrastructure. Search rankings, spam detection, speech recognition, translation, maps, YouTube recommendations, Gmail autocomplete. Google Brain wasn't just building AI. It was turning the entire Google ecosystem into an intelligent organism. But there was a problem, one so large that it threatened the entire future of AI. GPUs, CPUs, even custom architectures, they weren't fast enough. Training deep learning models required not just hundreds of machines, but thousands. Costs skyrocketed. Energy consumption ballooned. Training times stretched into weeks. Larry Page had a vision to compute faster than the laws of hardware allowed. But Sergey Brin had something else. A question, one he asked during a hardware strategy meeting. Why are we depending on chips designed for video games to power the future of intelligence? The room went silent. Engineers exchanged glances. Someone finally asked, timidly, "Are you suggesting we build our own chip?" Sergey said nothing. Larry answered for him. Yes. Thus began one of the most ambitious engineering efforts in the history of computing. The Tensor Processing Unit. Designed from scratch. Optimized for AI. Built for speed. Built for scale. Built for the future. The TPU wasn't just faster. It wasn't just efficient. It was a declaration. Google refused to let the physical world limit its pursuit of intelligence. When they first tested TPU v1 on a production workload, engineers measured the throughput and fell into stunned silence. Some stared at the numbers as if they were hallucinating. It was 10 times faster, then 20, then 50. When Larry saw the benchmarks, he only said, "Good. Now make it 100. The TPU became the engine powering Google Search, Translate, Photos, Gmail, and, eventually, Google's most advanced neural networks. Without it, the next chapter of AI, the chapter that would change the world, could never have happened. AI was no longer a research project, or an infrastructure upgrade, or an internal tool. It had become Google's identity. But the watershed moment, the one historians would one day point to, came when a model called AlphaGo defeated the world champion Go player, Lee Sedol. For Larry and Sergey, AlphaGo was more than a triumph. It was a message, a clear, undeniable signal that intelligence, real, emergent, strategic intelligence, had arrived. Not artificial, not simulated, but something new. The world gasped. People began to understand something Google had known for years. The age of AI wasn't coming. It had already begun, and it was running on the infrastructure Larry Page and Sergey Brin had spent 2 decades building. When every product became a mind. In the years following AlphaGo's triumph, something shifted inside Google. Before, AI had been a tool, one of many engineering strategies used to refine search, improve infrastructure, or enhance user experience. But now, AI was no longer a component. It was the philosophy of the company, the grammar of its decisions, the bloodstream of its ecosystem. Sundar Pichai, now CEO, stood on a stage at I/O and announced, "We are transitioning from a mobile-first world to an AI-first world." But the shift had begun years earlier, conceived by Larry and Sergey in countless private conversations, walks around campus, late-night strategy sessions in glass offices overlooking shoreline, debates over how to balance ambition with responsibility. The founder's vision was simple, bold, and impossible. Every Google product would become an intelligent system. Search would predict what people needed. Maps would foresee traffic before it existed. Photos would transform memories into searchable knowledge. Gmail would complete your sentences. Assistant would become conversational. Android would learn from billions of devices at once. Chrome would adapt to the behaviors of entire populations. YouTube would become a living algorithmic organism. To outsiders, this transformation looked smooth, inevitable even. Internally, it was chaos. Thousands of teams restructured. Code bases were rewritten. Data pipelines expanded into planetary superhighways. New ethics boards formed. Old hypotheses died. Many engineers panicked. Some resisted. Others embraced the change with monastic devotion. But through the turbulence, there remained a constant. Larry Page's conviction that intelligence at scale was the only path to a more capable future. One evening, during an internal fireside chat, he said quietly, "We are not building apps. We are building a brain." And for a moment, the auditorium fell silent, because everyone understood he wasn't speaking metaphorically. Search had once been a hand-built machine, a mass of heuristics and clever rules refined by human insight. But machine learning changed everything. Rank brain, neural matching, AI systems that went beyond keywords, beyond semantics, into meaning itself. With these systems, search became something new. A global oracle. It no longer merely retrieved information. It interpreted intention. A teenager in Manila typing, "Why does my chest feel tight at night?" was interpreted differently than a 55-year-old in Toronto typing the same question. A single phrase, "How to start," could lead to results about businesses, hobbies, new careers, or self-improvement, depending on subtle behavioral cues Google had learned to detect. And Larry would insist, in every meeting, don't just make it accurate, make it helpful. He wanted a search engine that could guide, not just respond. One that understood the urgency behind a query. One that could read the emotional contour of a sentence. The team built models capable of evaluating search results with human-like criteria. They built trust systems to downrank misinformation. They built knowledge panels that summarized the world. Search became an instrument of intelligence, a conduit through which billions communicated with the digital universe. And yet, Larry believed search was still only in its adolescence. He told a friend once, "Someday, you won't search. You'll simply ask, and the world will answer." Sergey Brin had always loved maps. To him, it was Google's most human product, a fusion of exploration, curiosity, and the raw structure of the planet itself. But AI changed maps in ways no one anticipated. Deep learning models began to predict traffic patterns using global signals. Location pings from phones, weather forecasts, historical data, special events, accident reports, sensor grids. The models began predicting traffic not seconds ahead, but hours, then days, then in some cases, weeks. Maps no longer described the world. It forecasted it. Larry once joked, "Maps knows what the city will do before the city does." The joke became true. Municipalities began quietly requesting access to Google's predictions. Logistics companies rebuilt operations around Google's time estimates. Emergency services used maps routing intelligence during disasters. Then came the AI-driven reconstruction of Street View, models that could identify signs, landmarks, storefronts, and even speculative changes to cities. For Sergey, this was a triumph. He said, "We turned the planet into a dataset. Now we're turning it into a model." Translate had been a pet project of theirs from the beginning. Born from Sergey's frustration reading foreign research papers as a student and Larry's desire to build a world where knowledge was unconstrained. But neural machine translation changed everything. When Google rolled out end-to-end deep learning translation, languages with almost no training data suddenly blossomed with new capability. Entire communities, previously cordoned off by language, were pulled into the global information network. Researchers called it magical. Linguists called it impossible. Larry and Sergey simply called it the future. One day, after a demo where Translate handled a notoriously difficult sequence of idioms, Sergey murmured, "We might live long enough to see a world with no language barriers." He wasn't exaggerating. AI-driven translation became one of the purest examples of how intelligence could elevate human life, not for profit, not for efficiency, but for connection. Google Photos became a neural memory, able to identify faces, emotions, objects, even stories within albums. Gmail became a mind-reading assistant, predicting text, sorting messages, deflecting threats. YouTube's recommendations became an engine of global attention, able to tailor an infinite stream of content with surgical precision. And the Chrome browser, running on billions of devices, became a global sensor for user behavior, feeding an ever-growing collective understanding of how humans navigate the digital world. AI became the invisible partner in every Google interaction. Not loud, not flashy, not advertised in neon, but omnipresent. Yet with great power came great tension. Inside Google, debates raged, quietly at first, then loudly, sometimes painfully, over questions that had no precedent in history. How much should AI know? How should AI decide? Who should control its boundaries? Where should the line between personalization and manipulation be drawn? What responsibility did Google carry as the steward of global intelligence? Sergey was often the conscience. Larry was often the visionary. Both wrestled with the same dilemma. We built the infrastructure for intelligence, Sergey said one night, but not the social norms to contain it. Google's ethics boards expanded. Internal guidelines evolved. Entire research teams were formed to study fairness, privacy, safety, interpretability. It wasn't enough for Google to lead in capability. It needed to lead in responsibility. This ethical awakening would eventually define the next era and shape the founder's own evolution. By the late 2010s and early 2020s, something extraordinary had happened, quietly, gradually, then undeniably. Google had become the central nervous system of human civilization. Its infrastructure powered global communication, global information retrieval, global navigation, global translation, global video distribution, global cloud infrastructure, global machine learning development, global AI research. No empire in history had ever held such influence. Not Rome, not Britain, not any nation or company. But Google's empire was not geographical. It was cognitive. Its borders were invisible. Its reach was universal. Its currency was intelligence. Larry Page once summarized this transformation in a single sentence that would later appear in biographies. We built a company to organize the world's information. Somewhere along the way, we began organizing the world itself. He didn't say it with arrogance. He said it with awe. This was not the future they predicted. It was the future they helped create. And yet, for all of Google's reach and brilliance, a new challenge loomed on the horizon, one that would redefine the next phase of Larry and Sergey's journey. The rise of generative intelligence, large language models, AIs that could create, not just interpret. The world was about to change once again, and Google would soon find itself in the most critical battle of its existence. By the early 2020s, the AI landscape had shifted yet again. Large language models, massive neural networks capable of generating text, images, and code, were no longer experimental curiosities. They were tools of creation. They could write news articles, generate software, compose music, and simulate complex scientific phenomena. Inside Google, the pressure was immense. Every research team, every lab, every division suddenly had to ask the same question. How do we integrate generative intelligence without losing the soul of our company? Larry and Sergey did not panic. They convened what would become known internally as the Founders Circle, a small, secretive group of senior researchers, engineers, ethicists, and product leaders. Over countless late nights, often fueled by coffee and leftover pizza from campus cafeterias, they debated, sketched, and argued over the future. Could Google create generative models that were safe and interpretable? Could they democratize these tools while preventing misuse? How would they transform search, maps, Gmail, photos, and YouTube when intelligence could now generate content autonomously? Sergey leaned back in his chair one night, looking out at the glowing lights of the campus. We've built the world's brain. Now we have to teach it to imagine. By 2023, Google had deployed Bard, its flagship large language model, alongside Gemini, a multimodal system capable of reasoning across text, images, and structured data. The ambition was staggering. Search became proactive, summarizing information before users even asked. Maps could simulate traffic and pedestrian flows for entire cities, offering predictive urban planning insights. YouTube evolved into a generative content platform, producing adaptive learning tutorials for millions. Gmail transitioned from smart compose to smart decision-making, proposing complete email strategies. Larry and Sergey watched as these systems, once theoretical, began reshaping user behavior, commerce, research, and government policy. Yet every success brought a storm of scrutiny. Regulators questioned privacy. Ethicists questioned creativity. Competitors raced to replicate or counteract Google's advantage. Larry reminded the team repeatedly, generative AI is not a product. It's a responsibility. We are custodians, not just builders. Sergey added quietly, if we fail to get this right, we don't just fail as a company. We fail as a society. 3. The ethical crucible. Generative AI forced Google into uncharted ethical terrain. The company had to balance innovation versus control. How much autonomy to give the AI? Access versus safety. How widely should powerful models be available? Profit versus responsibility. How to monetize without harming society. Ethics boards expanded into dozens of specialized teams, monitoring bias, hallucinations, misinformation, and environmental costs. Larry and Sergey insisted on transparency. Every model must be auditable, every decision explainable, every potential harm considered before deployment. The stakes were personal. Each misstep could damage the reputation of the founders, the company, and the very concept of safe AI. And yet, they pressed forward. Because the alternative, hesitation, meant letting others define the future. Generative intelligence accelerated Google's dominance. Enterprises integrated models into workflow automation. Healthcare systems used AI to propose treatment plans. Universities offered AI-assisted research. Governments used models to analyze policy impacts. Google's cloud platform became the backbone of countless AI startups and global projects. Every new AI initiative, from protein folding to climate simulation, relied on Google's infrastructure. Larry and Sergey were no longer just founders. They were architects of the planet's cognitive infrastructure. They held private meetings with world leaders, CEOs, and heads of research labs, often emphasizing the same message. Intelligence is a public good. We must build it responsibly and give it wide access, or the risks outweigh the benefits. The message resonated, but it also drew competition and suspicion. Other tech giants began deploying their own generative AI platforms, sometimes in secrecy, sometimes with aggressive PR campaigns. The race was on, and Google had both the lead and the target painted on its back. Amid the whirlwind, Larry and Sergey found rare moments to reflect. Larry often walked the trails behind the Googleplex, pondering the philosophical implications of a world increasingly guided by AI. Sergey preferred quiet evenings in labs, tinkering with prototypes, exploring model architectures, and imagining new possibilities. They discussed legacy, not in terms of wealth or market share, but in terms of humanity. How would future generations remember this era? Would AI elevate human potential or diminish it? Would the company they built stand for intelligence or for control? They did not always have answers, but they had conviction that Google's mission, to organize the world's information and make it universally accessible and useful, remained their guiding light. Despite the empire they built, Larry and Sergey never lost sight of the human impact. They received letters, emails, and messages from people whose lives had been changed. A student in Nairobi who used AI-powered search to win a scholarship. A small business owner in Buenos Aires who optimized logistics with AI, saving his company. A hospital in rural India that used predictive models to anticipate outbreaks and save lives. These stories were reminders that behind every algorithm, every model, and every teraflop of compute, the real measure of success was human. Larry whispered during one review session, "We are not just building intelligence. We are building hope." Sergey nodded. "And that is why this work matters more than anything else in our lives." By mid-2024, the Google AI empire was fully realized. Search, Maps, Gmail, Photos, YouTube, Cloud, TPU infrastructure, and Google Brain all interconnected through generative intelligence. Google became the central nervous system of modern cognition, powering billions of daily interactions. Larry and Sergey, through vision, patience, and relentless curiosity, had guided humanity into a new cognitive era. Yet the founders understood that the journey was far from over. Generative AI was only the beginning. The world was changing faster than any single company could predict. New ethical dilemmas, technical challenges, and societal implications awaited. And in those challenges lay the opportunity to leave a legacy far beyond technology, a legacy of intelligence, responsibility, and human flourishing. Larry Page and Sergey Brin, sitting quietly in one of the upper floors of the Googleplex, looked out over the campus at sunset. They said nothing. They didn't need to. The empire they built spoke for itself. The world was listening. And the story of intelligence, both artificial and human, was just entering its most ambitious chapter yet.